Today we're working our way backwards. We are given information about a quadratic function, and we are going to write the equation from that information. When we're writing equations, we really cannot start with standard form. We can start with vertex form and intercept form. So the main thing is to remember vertex form gives us HK, our vertex, which means if we are given a vertex, this is the form we're going to want to start with. Intercepts form gives us our x-intercepts, P and Q. So if we're given x-intercepts in our information, this is the form we want to start with. So look at our first example. We are given the x-intercepts of 1 and negative 2. This means we have an x-intercept at 1, 0 and at negative 2, 0, and they gave us another point on the graph, which we need. So, excuse me, given the information which form would be best to use to write a quadratic function, they gave us the x-intercepts, so we're going to use x-intercept form or intercept form. So y equals a times x minus p times x minus q. All right, and here's what we have. They gave us an x-intercept of 1 and an x-intercept of negative 2. They also gave us this point, which is our x and y. So we have our y and we have our x that we can all substitute all of this in. So what variable is unknown? The a variable is our unknown right here. So this is what we're going to have to find. Oh, so a. Okay, so we're going to plug in what we have. So I kind of just showed you where to put everything. So we have 12 equals a times 2 minus 1 times, and be careful here because this is 2 minus negative 2. All right, so when we put all this together, 2 minus 1 is 1. 2 minus negative 2, which turns to plus, is 4. So we have 12 equals 1 times 4 is 4a. When we divide, 12 divided by 4, 12 divided by 4 is 3. So it says write the function in intercept form and standard form. We are actually skipping standard form right now because we have not reviewed a certain concept. So to write the equation in intercept form, we just go back to where we started. We have y equals, now we know what a is. It's 3 times x minus 1 times x minus or plus 2. So this is our intercept form. And then we can graph. Okay, so I have x-intercepts at 1 and negative 2. And then I can use those intercepts to find my axis of symmetry. So x equals 1 plus negative 2 divided by 2. So 1 minus 2 is negative 1/2. All right, so I'm going to negative 1/2 to draw my axis of symmetry. And then I can substitute that. So y equals 3 times negative 1/2 minus 1 times negative 1/2 plus 2. Negative 1/2 minus 1 is negative 1 1/2 or 3/2. And negative 1/2 plus 2 is a positive 3/2. So negative 3/2 times positive 3/2 is going to be a negative 9/4. And then I multiply that times 3. Ooh, and I get negative 27/4. So 4 divides into negative 27 negative 6 times and 3/4. So my vertex is negative 1, negative 6 and 3/4. So down here to 6 and 3/4 is going to be almost to negative 7. And there we go. So this one says given the information, which would be the best form to use. We are given the vertex, so we're going to use vertex form. And so what do they give us here? They gave us our vertex of 1, 5, and they're giving us this point, which is an x and y value, so negative 13 and negative 2. So our unknown is this a. Okay, and so that's what we're doing. For writing the equations, we're usually looking for a, and then we have our equation. So let's plug in our stuff. So we have negative 13 equals, we don't know what a is, negative 2 minus 1 squared plus 5. All right, so negative 2 minus 1 is negative 3 squared. And then we have negative 3 squared is 9. So I'm going to actually put 9a here plus 5. And so we'll subtract 5 from both sides. Negative 13 minus 5 gives me negative 18 equals 9a. And if I divide by the 9, I get a equals negative 2. Okay, again, we're skipping the standard form this round because we haven't talked about something. And so we'll substitute the a back in, leaving the x and the y. So it's y equals a is negative 2. And then we have x minus the 1 squared plus the 5 at the end. And so that's our equation in vertex form. So now we're given a graph, and we are going to write the equation. So let's take a look at this graph. This graph is a nice graph because we have a vertex right here, which is 4, negative 2. They also give us our x-intercepts of 2 and 6. And we can pick another point on the graph, and I'll tell you one of my favorite points to pick if able is the y-intercept because 0 makes things easy. All right, so we have a choice. We have our x-intercepts and we have our vertex. So for this one, we could choose both or either. We could choose either one. I am actually going to do both just to show you. So if I start with the intercept form, because that's the first thing on my list, and I'm going to use this point. So that means I have y equals a times x minus p times x minus q. And they've given me the 6 equals, I don't know what a is. My x is 0 minus a net intercept is 2, and then 0 minus the x-intercept of 6. So what I have here is 0 minus 2 is negative 2. 0 minus 6 is negative 6. Negative 2 times negative 6 is 12. And when I divide by the 12, I get 1/2 for my a value. Now, since we're not writing this in standard form, I'm just going to strike through this, and I'm going to write my equation down here. So I have y equals, now I know what my a is, x minus 2 times x minus 6. So that's my equation in intercept form. Then we have our vertex form. So I'm going to come over here and I'm going to do my example in vertex form. Y equals a times x minus h squared plus k. So for my y, I have 6. I don't know a. For my x, I have 0. For my h, I have 4 squared plus negative 2. So 0 minus 4. And should we get the same a? Most definitely we should. So we should expect to get 1/2. 0 minus 4 is negative 4 squared, and plus a negative 2 is the same as subtract 2. So we have negative 4 squared is 16a. I'm going to add the 2 over here. 6 plus 2 is 8 equals 16a. And then I divide by the 16. 8 over 16 is 1/2. All right, so the equation in vertex form is going to be y equals 1/2 times x minus 4 squared minus 2 or plus negative 2.